All right, so today we are going to talk about finding the volumes of prisms and cylinders. So prisms and cylinders are relatively pretty much the same thing. The only difference is that cylinders focus on having a circular base, right? And so we spent last week talking about finding circumference, an area of a circle, and specifically finding the area of a circle is what is going to be valuable for us to know when it comes to finding the volume of a cylinder, right? So hopefully you kind of have a general idea of what a cylinder is in your mind, but a cylinder is just like a soup can, right? It's got a circle as the base, and it's got a circle on top, and all that really happens, ooh, that's really bad, is that our circle gets translated basically up and down, right? And so we have this three-dimensional shape, and instead of just having area, it's got a volume, right? And volume is just three-dimensional space. How much three-dimensional space does it take up? Nearly everything we interact with in our daily life has volume, right? It takes up space, and for a lot of things, it's difficult to calculate because they're not very regularly shaped, but they are taking up some amount of space, and volume is one way that we can kind of quantify that, right? So that would right there be a cylinder. A prism is just a more regular base, so a square base or a triangle base. And then when we translate that up and form a three-dimensional object, we get a prism. So if you guys have ever drawn like a cube before, where you do like the two squares, right? And then you connect the corners, that's a prism. We could also have a triangle, right? That gets translated down, and we would have that would be a triangular prism. This would be a cube. A rectangular prism would be where we have a rectangle that we translate down, right? And so while being able to draw them might be a little bit cool, it's also kind of valuable when it comes to calculating their volumes, because it's a lot easier to calculate the volume of something that you can kind of look at as opposed to something that you don't see, right? And they don't necessarily have to be straight up and down. They could also be kind of diagonal, right? So we could have something like that, right? Let's see how well I can draw this. That's supposed to be kind of a diagonal rectangular prism. That is not drawn very well, but that's all right. So to find the volume of a rectangular prism or a cylinder, or something that looks somewhat like this, where we have a base and that base is just translated up through the shape, giving it a volume, the general formula is pretty straightforward. Volume is just equal to the base times the height. Okay, and so where these different prisms vary is with that base, right? So with a circle, to find the area of the base, I need to use my area formula, which is area equals pi r squared, right? Or instead, if I had a square, right, the area of a square is just side squared because both of the sides are the same length. Or if I have a rectangle, the area of my base is length times width, right? Length times width. Or if I have a triangle, my area is 1/2 base times height of the triangle, right? So what the difficult part is finding the area of the base, and then beyond that, all we have to do is multiply it by the height, okay? So I think the easiest way to go about this is to look at an example. So let's look at example 1. Right. So example 1 is a triangular prism. So a triangular prism, we'll see how I can draw this. Okay, that's a little bit wiggly, but that's okay. Okay, and then we know the measurements are 3 centimeters by 4 centimeters, and the height is going to be 2 centimeters. Okay, so whenever I'm going to find the volume of a prism or a cylinder, the first thing that I want to do is identify what the base is, right? Because the first thing I need to do to find the volume is to find the area of the base times the height. Okay, and so the book uses just this base times height formula up here. I like to use something like this because that A with the subscript B is telling me I want to find the area of the base, right? And so that's going to kind of be my first step. And with the triangle, we have what we call a base side, and so it makes it slightly less confusing to say, well, am I taking, the base of the triangle times the height of the prism? No, we want to find the area of that triangle, and then we want to use height to find it, right? And the reason this works is because if I find the area of this little triangle here, right, and the height tells us how many of those little triangles happen between the top and the bottom, right? So think about a bunch of those little triangles stacked up, right? And each of them have some tiny little height, and we stack all those heights together, and we get 2 centimeters, right? And so you can kind of think about it like a piece of multi-layered cake, right? There's a bunch of layers in there, and we're trying to count up each of those layers. Well, for each layer, we have some area, and we have to use that however many times the height tells us that we should, right? So first things first, I want to find the area of the base. So I want to find the area of this triangle, and you'll recall hopefully that the area of a triangle is 1/2 base of the triangle times the height of the triangle, right? So I don't have to think about the height of my prism yet. I'm just focusing on the base and height of my triangle, and this is a right triangle, right? So the base is 3, the height will be 4, so I can plug those in. 1/2 base of 3 times the height of 4, right? And so 3 times 4 is 12, times 1/2 gives us an area of the base of 6, right? So now I go back to my volume formula, which is the area of the base times the height, right? And I guess side note here before we do that, the area of the base is going to be centimeters squared. And then the height is 2 centimeters, right? That means that we've got 2 centimeters worth of these little 6 square centimeters triangles that we are kind of layering on top of each other, right? So then I want to multiply those together. 6 times 2 is obviously 12. And then with volume, when we had length, our units were centimeters, just centimeters, right? When we had area, it was centimeters squared. And now that we have volume, that's going to be centimeters cubed, right? Representing those 3 dimensions that we're multiplying together. And so 12 centimeters cubed would be the volume of this triangular prism, right? So hopefully not too bad. The tough part is just going to be this part where you're finding the area of the base. Okay, and if that's a rectangle or a square, it's pretty easy. But if it's a triangle, maybe it's slightly more difficult. I avoided putting any trapezoidal prisms on your homework because I doubt that you guys remember the area of the base of a trapezoid. But if you did want to find and try some of those, the area of the base for a trapezoid is base 1 plus base 2 divided by 2 times the height. Right, and that's just for any of you that want to go try a trapezoidal prism. Okay, let's do one more example of a cylinder. Okay, example 2, and this time I'm just gonna kind of tilt it like you kind of pushed it. You've seen There's trees that are kind of tilted over, right? They've been in the ground so long and it's been heavy winds and water or something, and the tree kind of tipped over a little bit. That's what this circular or cylinder is going to be, right? So the question is, how well can I draw it? Not bad, not bad. Okay, so I know that the radius of the circle is 4 centimeters, and the height is 7 centimeters. So when they give you the height, it's the distance between the top and the bottom. Okay, so it's going to be this right here is 7 centimeters. It's not. Let's see if I can. It's not this length here. What we care about is the total height between the top and the bottom, right? And that the reason that is kind of maybe a little bit more of a calculus topic that deals with infinitely small slices of circles, if you will, but nonetheless, that 7 centimeter height is what you want to focus on. That's what should be given to you when you do the problem, so it shouldn't be too hard, just that's what you want to focus on, right? So to find the volume, we want the area of the base times the height, and because we have a circle, the area of our base, so we're going to use the formula for the area of a circle, which will be pi r squared, okay? And r is the radius, or 4 centimeters, okay? So I've got pi times, my goodness gracious, 4 centimeters, and that's squared, okay? Well, 4 squared is 16 times pi, and that'll be centimeters squared, right? Because that's an area. So now we have the area of the base, which is 16 pi, and we want to find the volume. So the volume is the area of the base, 16 pi centimeters squared, times the height, which is 7 centimeters. And this is where you might want to pull out a calculator unless you know that in your head. I'm going to get one out myself. So 16 times 7 is 112. And then we can't forget about the pi, which we haven't multiplied in yet. And we are in centimeters cubed. Okay. Now, you'll recall that we talked about an exact answer. Whenever you have pi, there's an option for an exact answer and then sort of a decimal answer. So if you were asked for the exact answer, that would be 112 pi. Alternatively, if you were asked for an answer with decimals, you would want to do 112 times pi and multiply that out, and then use however many decimal places it asks you to use. All right, so 112 times pi is 351.86 centimeters cubed. Okay, and that will be the volume of the entirety of this cylinder here. So hopefully that is pretty straightforward, right? So whenever you're going to do a volume problem, you want to first, step 1, you want to find the area of the base, and then step 2, you can find volume. All right, I think that's going to make it easier for you. And area of the base, if it's a triangle, you use the formula for a triangle. Circle, area of a circle, prism, or a square, rectangle, length times width, okay? So hopefully that is all right with you guys. If you have any more questions, definitely send me an email. Let me know. I will try my best to help you out. And yeah, shoot me an email if you have any questions. Hope you guys are all doing well. Only 2 weeks to go.